to recap for our little Narnian, he's off in Narnia, we're doing arithmetic sequences, and arithmetic sequences are sequences where the successive terms have the same common difference. Like this one has a common difference of 2, and we're calling that common difference D for difference, I guess. Here we have a sequence 4, 8, 12, 16. You notice that you add 4 to each one, and then Gary just knocked one out of the park. The sequence is 7, 11, 15, 19. A common difference is 4, and he found that the nth term was 4n plus 3. Here is another sequence. It's 2, negative 3, negative 8, negative 13, dot, dot, dot. I want to know what is the common difference, and what is the nth term. Starting with the common difference, what is added or subtracted from each term to get the next successive term? Yeah, we're subtracting 5, right? 2 minus 5 is negative 3, negative 3 minus 5 is negative 8. Now for the more challenging part, what is the nth term? So, yeah, negative 5n plus 7. But this was supposed to be easier. 1 5/4, 3 halves, 7/4. What is the common difference? And what is a sub n? Wow. So what do you add to get from 1 to 5/4? 1/4, right? Because 4/4 plus 1/4 would be 5/4, right? 5/4 plus 1/4 would be 6/4, which would simplify to 3/2. So we have a common difference of 1/4. Now the nth term is going to be rough, unless Courtney has figured out the pattern. Has Courtney figured out the pattern? No? Gary's figured out the pattern. Yeah, this common difference ended up here, and coincidentally this common difference ended up here. So we might think that this common difference might end up here. So if that's the case, it's going to be 1/4 times n. Here are your n's. 1, 2, 3, and 4. Plus or minus something. So 1/4 times 1. Do what? Plus 1? Okay, try it. 1/4 of 1 is 1/4. Plus 1 would give us 5/4. Not 1, so we got to re-guess. If we added 3/4, 1/4 of 1 is 1/4. Plus 3/4 would give us 4/4, which is 1. It's got to work for not just one term, but all of them. 1/4 of 2 is a half, which is 2/4. And if we add 3/4 to 2/4, we get 5/4. 1/4 of 3 is 3/4. 3/4 and 3/4 is 6/4, or 3/2. So this does work. So what we've discovered was known to mathematicians as the G-Spaz theorem, because G-Spaz came up with it. So, and what that is to find the nth term of an arithmetic sequence. Put this in big letters and underline it and make half of it yellow and make the other half whatever that is. Because it's arithmetic, we're going to learn another sequence called geometric, and this will not work for that. It only works for arithmetic sequences. The nth term of an arithmetic sequence is given by the common difference times n plus this other number c. Now what is this other number c? We know d is the common difference, which is the difference between any two consecutive terms. C is the difference between the first term and the common. The first term was 1, the common was 1/4, that's a difference of 3/4, and we added 3/4. The first term was 2, the common difference was -5. When you subtract -5 from 2, you get +7, which was our C. First term is 7, difference was 4, 7 minus 4, 3. Right? Okay. So that should make this oh so much easier. Maybe be too easy, and then we'll have to ramp up the difficulty again. You never know. Okay, find the nth term where the common difference is 3 and a sub 1 is 2. Remember, a sub 1 or a1 is sequence notation for the first term. So we have the first term and we have the common difference, which is everything you need to find the nth term of a sequence. So it's supposed to be dn plus c, and d is 3, so it's 3n. Now as for the plus c, our c is the first term minus the common difference. 2 minus 3 is -1. So the nth term is 3n minus 1. See, I told y'all it's going to get easier. That was almost too easy, wasn't it, Sarah? I mean, really? Courtney's yawning. She's like, oh, this is too easy. Okay. The fourth term is 20. And the 13th term is 65. Find the nth term. Wow. Find the nth term. What? 5 what? 5 times n? Because why? Where's that coming from? So he's saying the nth term, do not question Mason, is 5n. Okay. What if 13 didn't go into 65 and 4 didn't go into 20? Okay, yeah. So this is, it's right, it is 5. This is a sequence without a C term. It's not plus or minus anything, it's just 5n. So let's treat it, and I don't want to say question mark, I'm just going to box it. Let's treat it as if 65 and 4 and 20 are not divided by 5. Okay, so give me a different line of reasoning. Something more general. Something will work whether that'll work out or not. There's a different line of reasoning. A to the fourth is A4 is 20, A13 is 65, and there's a whole bunch of terms in between. If you really wanted to write out all those terms in between, what would you do? Well, we have, let's just call it D. So you have you have A4, right? It's 20. What would A5 be? If we didn't know, if we didn't have Mason. By what? Gary didn't say anything. If the common difference is D, what would A5 be? Huh? Yeah, right? Because you keep adding your, that's what you keep doing, is you keep adding your common difference. So A6 would be whatever A5 was, which is 20 plus D, and you'd add yourself another D, right? And A7 would be 20 plus 2D, and you'd have to add yourself another D. So when we get down, all the way down to the 13th, how many D's are we going to add to this thing? How many? Added 9 D's. So could you just like take 4 from 13 and yes. Yes. I just wanted to make sure everybody followed that reasoning. Huh? Yeah. So think about A13. It would be whatever A4 is plus 9 of these D's, right? A13 is 65. A4 is 20. That leaves you with an equation with one unknown, which means you can solve for D. So given any two terms, we can still find our common difference because we know it's an arithmetic sequence. And 65 minus 20 is 45 divided by 9. And we find out that D is 5. I told you. These are all arithmetic terms. After tomorrow, you need a little more information. You need to know it was arithmetic or geometric. So there's D, but we need the first term to write what AN is if we hadn't have realized the 5n part. How could you get the first term? You go backwards, yeah. You want to subtract D from 20 and then do that how many times? 4 times. That would get us back to, yeah. So A1 is what? What's that leave for A1? 5? 5 minus the common difference is 0. So there is no C. Remember that. Given any two terms in the sequence, we can still do it. Okay. Let's find the 9th and the nth term of an arithmetic sequence that begins with 2 and 9. Find the 9th and the nth term of an arithmetic sequence that begins with 2 and 9. We need to know what's the common difference? What's C? First two terms are 2 and 9, so what's common difference? 7. C is the difference between the first term and the common difference. It's the first term minus the common difference. Is -5. So the nth term is 7n minus 5. So the ninth term is 7 times 9 minus 5, or 58. Piece of cake, right, Sarah? Sums of arithmetic sequences. The sum, what do we mean by sum of an arithmetic sequence? We mean where you take all the terms of your arithmetic sequence and you add them up. So for this particular here's a sum for a particular sequence. 7, 9, 11, 13, 15, 17, 19. So there's a sequence. There's the first 10 terms of a sequence, and to sum the first 10 terms, you could A, put them in your calculator, 1 plus 3 plus 5 plus 7 plus 9, yada yada yada. Of course, if it said find the sum of the first 230 terms of the sequence, then that would take it way too long. So there should be an easier way, and there is. This has a common difference. 1 plus 2, 3 plus 2 is 5 plus 2 is plus 2 plus 2 plus 2. So it is an arithmetic sequence. And we have another formula. That's the sum of any number of terms of a arithmetic sequence is the number of terms divided by 2 times the quantity, the first term, plus the last term. So the sum of the first 10 terms divided by 2 times the quantity, first term is 1, 10th term is 19. 1 plus 19 is 20, divided by 2 is 10, times 10 is 100. So for the sum of an arithmetic sequence, we need to know the number of terms, and we need to know the value of the first and the last term in that sequence. If we're not given that, we have to find a way to find it. Sum of the integers 1 to 100. There is looking for these. There's one of the more famous stories from math about this problem. I can't remember what age he was, but he was very young. Gauss, the guy that came up with that elimination stuff that we did last week, he was being a pest, and the teacher told him to go to his desk and sit down and add all the numbers up from 1 to 100. And very early on in doing this, he realized that you could pair those up. Like there are all sorts of pairs that add up to 100, like 1 and 99 and 2 and 98 and 3 and 97. And you could pair those up and count the number of pairs that it makes and have your counting done. So that basically what he did was use this formula. The sum of the integers from 1 to 100 is an arithmetic sequence because you add 1 each time. Common difference, so it's an arithmetic sequence. So the sum of the first 100 numbers be 100 of them, which can be paired, as in divide by 2, paired, and the first plus the last. So we have 50 times 101, or 50-50. And as I heard the story, he came back in a few minutes with this number, and the teacher had to go back and manually add up the numbers to check his work. That'd be kind of a bummer. Pretty decent stuff though, right, Sarah? Sarah's happy. Find the sum of the first 150 terms of the sequence that goes 5, 16, 27, 38, 49. Two-part problem. Find the sum of the first 150 terms. So you think of that little sum formula, and you think, okay, it's 150 divided by 2. The first term is 5, and the last term is, we don't know the last term. So you can't use the summation formula right away. But we know it's arithmetic, and there's a common difference, and that common difference is what? 11. 11. And C is that first term minus 11. And the nth term is 11D minus 6. So the 150th term is 11 times 150 minus 6, or 1644. So the sum of the first 150 terms here is 150 over 2, first plus last. Still pretty groovy, right, Sarah? That's how Sarah sounded. She went, boom. Looks like a lot, but it's really not. It's only the first few out of each section. If there's some kind of random quiz tomorrow, it will be from one of those sections. So I suggest you definitely do a couple out of each if you don't do them all. If you're pretty confident that you can do one or two of those in under 5 minutes, then you probably don't have to do them all. If you're not, then you should probably be on the safe side.